Can fluid mechanics be used to predict weather patterns? In recent news, many are curious about how fluid mechanics plays a role in predicting weather patterns. With climate change and extreme weather events on the rise, understanding these concepts is more relevant than ever. People are searching for answers on how scientists can forecast storms, rain, and temperature changes. Fluid mechanics is essential in this field because the atmosphere behaves like a fluid. This means that the laws of fluid dynamics apply to air and water movements. Weather systems, including wind patterns and ocean currents, are results of these interactions. Meteorologists use fluid mechanics principles to study these phenomena. Models used in weather forecasting often relying on equations from fluid mechanics. One key set of equations is the Navier-Stokes equations, which describe how fluids move. These equations help simulate atmospheric flows, making predictions more accurate. For instance, the Surface Quasi-Geostrophic model is a two-dimensional fluid dynamics model that studies geophysical flows. Recent research shows that turbulence in these models can exhibit chaotic behavior. However, it also has predictability linked to fluid dynamic properties. This means that while some aspects of the weather are unpredictable, others can be forecasted with reasonable accuracy. Fluid mechanics is particularly helpful in understanding specific weather events like tropical storms and hurricanes. Improved models can enhance the accuracy of these forecasts without relying solely on expensive experimental methods. For example, the transport of particles such as snowfall and aerosols is analyzed through fluid dynamic models to improve predictions. Global weather forecasting systems combine fluid mechanics with data on ocean temperatures, wind patterns, and atmospheric conditions. This integration allows for predictions of seasonal and short-term weather changes. However, the chaotic nature of atmospheric flows presents challenges. While fluid mechanics provides a solid foundation for weather prediction, there are limits due to turbulence and nonlinear dynamics. In summary, fluid mechanics is vital for modeling and predicting weather patterns. It describes how air and water masses interact and behave. As technology advances, fluid dynamic simulations continue to improve the accuracy of weather forecasts. Understanding these principles can help us better prepare for the weather ahead.